in the past we've seen this table before. Now look at this one here. So in this video, we're going to work out how many terms we will need in order to get natural log 1.2 within an area of at most 0.0001 within this. Okay, so now let's just zoom into this bit. That will then take us to here. So we're trying to work out how many terms we would need to get to within a certain amount of error. So working out natural log 1.2, that's the same as us working out 1, and then this is our 0.2. So this in a way is like our x. So we can put 0.2 in here, 0.2 into here, 0.2 into here, and so on. So our series will be this. So basically we're putting 0.2 into this here because x here is 0.2. In our case, it's 0.2. Well, 0.2 is 1 over 5. So visualize 0.2 as this. So now it's 1 to the power of n, 5 to the power of n, and visualize divide as this. And then this gets multiplied to the bottom. So that will then take us to here. So now we need to make sure that that this is an alternating series. So make sure all three conditions have been met. So our normal routine would be to discard the alternating component, to discard this bit, and just concentrate on the UN. Make sure all the UNs are positive. So well, you can see n is moving from 1 to infinity. N is always positive. So UN here will always be positive. So this is good. And then check that it's non-increasing. Just glancing at this, you can tell it's getting smaller and smaller and smaller. So this has been met. And then make sure the limit is 0. The limit of this is indeed 0 because as n gets bigger and bigger, the denominator will just get bigger and bigger. 1 over the whole thing here will head towards 0. So all three conditions have been met. Then we know we can apply. We know that this will be true. We've seen this before. If you have an alternating series, well, we've done this many times. So track back to one of the early videos if you don't understand this. The remainder will always be less than or equal to the very first term. The remainder will be less than or equal to this term here, the value of this term here. In our case, it will be this because hang on, let's look at this. So this is our alternating series. This whole thing here is our alternating series. So if you want to know the remainder will always be less than or equal to the value of this thing here. Well, in our case, it's this. It will be earlier. Earlier was this n and then 5 n plus just n, and then so that's this thing here is this, but then the remainder will be less than the value of this thing here, which is the next term. Well, the next term will be n plus 1, which is n plus 1, and then you've got your n plus 1 here. So so this would be this value here. Okay, so so this is our remainder. We require our remainder to be less than 0.0001. This was in the initial question. So we require our remainder to be less than this. So now it's just a matter of working out n. So take the reciprocal. So when you take the reciprocal, the sign switch over. So that will then take us to here. Now, because we don't really know how to solve this, we're just going to guess. We're trying to search for a value of n, where the lowest value of n, where this side will be bigger than this side. So let's guess. When n is 3, put it into here. 3 plus 1, and then put it into here. That will then. Well, when n equals 3, this this value here is smaller than 10,000. So this is no good. When n is we're trying to search for a value of n where this would be bigger than this. Well, when n is 3, this is smaller than this. Well, when n equals 4, it actually becomes this, which is bigger than 10,000, which is bigger than 10,000. So you will need 4 terms. Okay, so hang on. So going back to here, so we would need 4 terms. So we would need 4 terms. So looking at this, we would need 1, 2, 3, 4 terms. Well, if you get a calculator and punch this in, it will then give you this. And remember, well, if we have 4 terms, our error will be within this amount. So what that means is this could be plus or minus this amount here. So looking at this, hang on, looking at this, this could be, don't forget, it could be minus or plus or minus. So this could be 3, or this could be 1. So if you're working within, if you're working to 3 decimal places, then you know 100%, you can be 100% sure that 4 terms would be good enough. Yeah, if you're working to 3 decimal places, you will know for sure that it will be good enough. Okay.